Good morning, everybody.
Good morning.
Good morning.
Good.
So Albert, did you have a Coke at 8:30, 8:40 in the morning? I mean, like you don't need that much caffeine in the morning.
I haven't even had
I mean, I'm not complaining. I'm not judging. I'm not judging. I'm just like,
I've had more
That's
today.
I mean, sometimes people put a lot more sugar than what's in the Coke in their coffee.
yeah.
All right, let's take a look here at the warm-up. So again, when you're finding the degree of the polynomials, you really have kind of like two different cases. You have when it's a monomial and when you have a polynomial. So I see three different polynomials up top. One's got 3 terms, one's got 2 terms, one's got 1 term. Can anybody classify that first one?
Isn't the degree just 4?
Yeah, classify in terms of how many terms it has.
Oh.
It's got 3 terms, so what would you call it?
Trinomial?
Trinomial.
Oh, trinomial.
Trinomial, right? That first one would be called a trinomial. Now, it asked you to do that on the homework, and you see that on the key. Make sure you do it. Whenever it says to classify, that's what I'm talking about. Make sure you call it a binomial, trinomial, monomial, whatever, polynomial, whatever it may be. So that's what you see on the key. Maybe you didn't do that. Catch that. The middle one there, that would be an example of a binomial. And then the last one would be an example of a monomial. Remember, trinomial is 3 terms, binomial is 2 terms, monomial is 1 term. If it's now, remember that these are all polynomials, right? Any set of terms is called a polynomial. And anything beyond 3 does not have a more unique name. It's just a polynomial. So if I want to find the degree of these polynomials, let me pull some names here. Dalton. Nope, Dalton. Dalton at home. What do you do? No, he's not watching. He's not watching this video. Dalton, if you're watching the video, shout out. Shout out. Dalton, if you're watching the video and you come to me tomorrow and say the code word is Coca-Cola. If you say the code word Coca-Cola, then I will give you a handshake. I don't know.
Give him an extra credit point too.
1 extra credit point?
Yeah.
Give him 2.
2?
Yeah.
Gio's being generous. Now, nobody can tell him.
Alright.
This needs to be like a real social experiment here. Okay, Anna, what's the degree of this polynomial?
The first one?
Yeah.
I got 6.
Okay, I see what you're doing there. You said the degree of this piece was 4, the degree of this piece is 2, the degree of this piece is 0, right? And then you added them together. Don't add them together. Not when it's a polynomial like this. When it's separated by multiple terms, you just take the biggest one. So you want to revise your answer? What would the degree be?
4.
Good. Same thing here for my second one. Luca, what's my degree of that middle polynomial? 5. Good. The degree here is 3. The degree here is 5. So the total degree of this thing is 5. Not 8, but 5. Now, this is when you add, okay? You see how there's no addition or subtraction signs? This is when you take the degree of the monomial, meaning you add. Nolan, what would be your degree for that last one? 5. That would also be a degree of 5. Good. With a 2 and a 3 added together. We add those together because you see just one singular term, monomial. Yeah.
So if you have a polynomial equation but it's multiplication, would you add them together?
Then it would not be polynomial. Well, then it would still just be a monomial. And yeah, you would add them together. Yeah. All right, taking a look here. When I add polynomials together, now, just as a reminder, do these parentheses really do anything mathematically? No. I just basically combine like terms. So, Nathan, what term should come first in my answer?
The 2x raised to the second power.
And what do I get?
8x to the second.
Good. And then what should come next?
3x and the negative 2x.
To make?
It's just x.
Good. And then I've got a minus 4 and a plus 8, which makes what?
Plus 4.
Good. So there's my polynomial. There's my polynomial. Polynomial with degree what? Somebody tell me. What's the degree of that polynomial? Yeah? 2. Right. The degree is 2. Can anybody identify the leading coefficient? The leading coefficient. Nick? 8. Good. first number all the way to the left when it's in standard form. Now, if somebody had given me the answer like this, would I accept that?
No.
No, because it's not in standard form. Gotta be formal about it, right? All right, Sid, what should be my first term in my second problem here?
6x.
To the
Third.
good, yeah. The reason I'd prompt you on that is because a lot of people might try to say that that's 6x to the sixth because you try to like add exponents or something. No. You don't need to add exponents. You just keep the same one because it's just combining like terms. And then what should come next?
Negative. No. 3x.
Good. I'm glad you corrected yourself because this minus 3x should come next and then the minus 16 should come. Okay? So she was about to say minus 16, but then she realized, oh, there's a 3x in the second one. That has to come before it in the final answer because of, again, standard form. It's got to go in order. And these are both in the end trinomials, right? You know, there is a more unique name that we could give it. We don't really talk about it too much, but it's there. You can also classify based on its degree as well. Like for this first one on the left side, you could call that a second degree trinomial. This would be a third degree trinomial. Up top in the middle, that would be a fifth degree binomial. This would be a fourth degree trinomial up top on the left side there. Jim.
If we're adding the things like
The terms?
yeah, the terms, we don't add like the exponents, we just like take the bigger one.
Correct, because we're combining like terms. We're not multiplying with those things. We are combining like terms. We'll start talking about multiplication tomorrow.
No, we're doing it. I think never mind.
Wednesday, Thursday, Friday. That's normal.
And our quiz is on Monday.
No, Tuesday.
We never right.
There's only 2 sections to this chapter? Oh.
There's 2 sections worth of multiplying. 7.2 and 7.3 are both multiplication. Questions about that? Okay, let's go through any homework problems that we want to go over. Honestly, I hope, did you guys find the homework kind of easy?
Yes.
I hope so, because it's really basic stuff. Adding and subtracting polynomials and identifying these things are really quite simple. You just got to know the rules to apply to them. I'll tell you right now, once we get into multiplication, that's a little bit more difficult. That will be the biggest, struggle this chapter probably. But for addition and subtraction, it's really not too bad. But again, are there any questions that we'd like to talk through?
Even though we didn't have to do number 2, wouldn't that have to be 0?
Yeah, good. Yeah, even if it's just a number, it's a 0. So like looking at number 2 there, that would have been a 0 degree. Just a number is a 0 degree. Yeah.
Can you go over 21?
Yeah. Let's take a look at 21. Oops, come on here. All right. Okay. So we have a 2n squared and a negative n squared to make a 1n squared, or honestly, you don't need the 1 there. And then we have a negative 5n and a negative 3n to make negative 8n, and a negative 6 and positive 11 to make a plus 5. A second degree trinomial. Some might call that a quadratic trinomial. Questions about that? Anything else on the homework that we want to talk through or go over? Yeah. 22. All right. 22. Negative 3p to the third and another negative p to the third. So negative 3 and a negative 1 make a total of negative 4. I've got a 5p squared and a negative 8p squared, so negative 3p squared. And then a negative 2 and a negative 15 to make negative 17. A third degree trinomial. Leading coefficient negative 4, degree of 3. Make sense? Anything else? So as promised, yesterday was about just identifying things and adding. Today is subtracting. Okay, today is subtracting. And I gotta be honest, it's really not too bad. There's just a couple things to watch out for. Really, again, not too bad. All right. Now, to subtract, like if you think about the operation of subtraction, to subtract is really to add the opposite of that number, right? Like if I had any number, any I won't say number, but any expression, like 3 minus 7, right? 3 minus 7. Couldn't I rewrite that? Couldn't I rewrite that to say an equivalent statement of 3 plus a negative 7? Right? That's always an option of rewriting any subtraction into an addition, and you're going to add the opposite, right? That's essentially what we do for any polynomial as well. To subtract a polynomial, remember that subtracting is really the same as adding the opposite, right? Subtracting is really essentially just adding the opposite of the thing on the right side. Like, also, let me point out, I mean, did I change the 3 at all? No, the only thing I did was just mess with the 7, right? Mess with the right side of the expression. I'm only messing with the right side of the expression when subtracting a polynomial as well. To subtract polynomials, remember that subtracting is the same as adding the opposite. To find the opposite of a polynomial, you basically just distribute the negative into the second polynomial. So again, you just leave the left side polynomial the same. But the right side polynomial becomes the opposite. And that opposite, I'm talking opposite of every single term on the right side. So the more the terms in the second polynomial, the more distributions of that negative you're going to have to do. Now, remember that this is kind of like saying you have room on your papers. I got to move this over a little bit. This is kind of just like saying, okay, any polynomial over here. Whatever polynomial is, it doesn't matter what's on the left side. Whatever is on the left side just stays on the left side and does not change. But what's on the right side, you have to take that negative, you have to take that minus sign and bring it in and distribute. So this positive 2x to the third would become a negative 2x to the third. This negative 3x would become a positive 3x. This positive 7 would become a negative 7, right? You have to take that, distribute that negative into the right side, and then at that point, that's when you can combine like terms, okay? So you distribute the negative, and then you combine like terms. And that's essentially it. That's really all you have to do when you're subtracting. That's the only new piece that we're talking about today. So I think I have to change this one. You do not have this problem, correct? Correct. And you guys have 2x squared minus 3x plus 1 minus x squared plus x plus 1. All right. Okay, so do we see a trinomial minus a trinomial? Right? Do the parentheses mean something now? Yes. We can't just erase them, right? Like we did yesterday with addition. We have to do something to get them to go away. And what do we have to do? We have to distribute that negative into the parentheses. Okay, now that means that my first term stays my first polynomial stays exactly the same. 2x squared minus 3x plus 1 stays the same. But the second side, the right side, just changes. This positive x squared becomes a minus x squared. This positive x becomes a minus x. This positive 1 becomes a minus 1. everybody's sign flips on the right side. And then we just combine like terms. At this point in this second step, and then, okay, now the parentheses are gone. We say 2x squared minus x squared to get x squared. We say negative 3x and a minus x to get negative 4x. We take a plus 1 and a minus 1, and that will obviously cancel. And there's my answer, x squared minus 4x. Yes, sir?
So you're taking the two numbers that, so you're just taking the two numbers that are equivalent and subtracting them?
Basically, yeah. I would strongly encourage you to write out the second step. Yeah, write out the second step of the distribution of the negative. Because if I would, I see in your brain, you're thinking, I can just bypass the second step and go right to the last answer, right? I would caution you against that because there are a lot of times when, you'll drop a negative somewhere. Yeah, the negative, you won't distribute a negative all the way in. You'll forget about it at certain places. So I would, again, strongly encourage everybody, even though you may be able to get to that answer most of the time, to eliminate any error that may happen, write out the second step. Because you're not going to make a mistake here when doing that step. Okay, let's do the next one here. Again, left side stays exactly the same. 7m to the fourth minus 2m squared. The right side distributed in. Okay, so this positive 5m to the fourth becomes a negative 5m to the fourth. This negative 5m squared turns positive 5m squared. This positive 8 turns negative 8. See, and this is a case where if you try to go straight to the answer, you might forget that negative has to turn positive. And now we combine like terms. Now remember, same rules apply. Put it into standard form. 7m to the fourth minus 5m to the fourth is 2m to the fourth. This negative 2m squared and a positive 5m squared becomes 3m squared. And then we tack on that minus 8. Pretty simple, right?
Yep.
Go ahead and do C and D on your own.
Negative 9 distribute to a little positive 9.
Okay, give you guys about another minute. All right. So let's distribute in this negative on the right side. Left side stays again exactly the same. Distribute on the right side. This becomes a negative x squared, and then this plus 9. Watch out for that. It's always when you're distributing to a negative that people tend to make their mistakes. All right, now we combine like terms. We have a negative 10 and a negative 1 to make negative 11. A negative 3x. Does that have anything to combine with it? Just drop it down. positive 7, positive 9, a plus 16. I bet if you guys made a mistake, you might have said negative 11x squared minus 3x minus 2. But if you made a mistake on that one, I bet it was a minus 2 sitting out there on the end. You know where that comes from? Forgetting to make the negative 9 positive and then combining with the 7. Always make that, distribute that negative. Even when you have a negative, turn it to positive. And let's take a look at the last one. Now, is there such a thing as standard form for this one? Not necessarily, because they both have degree of 2, right? I guess you could think about them in alphabetical order, sure, whatever, but that's not a a set rule. Again, first polynomial stays exactly the same. Don't touch that. The second polynomial is the one that changes. This is a minus 5r minus 4s. And now we combine like terms. Negative 4, negative 3. And there we have our answer. How do we do on those two? Good? Good. All right. I'm giving you 17 minutes on purpose. I want everybody working on their online assignment because, in my opinion, typing in polynomials is one of the more difficult things to do. Like when you get to your state test, you might be thinking, well, how do I get it up in the exponent? How do I get it down from the exponent now? So that's one of the more difficult tasks, I think, typing in wise, logistical wise. So I want everybody to go to the that DIM app tool on the left side of Canvas and do your online assignment. I'm giving you enough time in class today that you should get this done in class today. Okay? So go ahead and get to work.
Yeah, okay.